Hi everybody, my name is Valentin. I've been working in the video game industry for more than 12 years now, out of which 4 in Splash Damage in London, UK. And we're here to talk about coding standards. So it's going to be a short focus talk, but we're going to cover some good ground. We're going to start by looking at the background of coding standards. This could be familiar, but it's still worth revisiting. Then we're going to talk about this new approach. And then we're going to look at themes and projects in the sense of adoption and enforcing standards and the dynamics there. So first of all, what are coding standards? If we literally read out the Wikipedia definition, it says that there are a set of guidelines for a specific programming language that recommend a style, practice, and methods for every aspect of that programming language. Now, a key difference is when these guidelines, when they're formally adopted, that's when they become standards. So let's look at a couple of examples in the wild. So let's start with the C++ ISO standard. Now, it's a bit cheating calling it a standard, because standard here means it's part of the ISO standardization body, which is in charge of actually defining the spec of the language. But nevertheless, it still gives some styling, especially with naming. For example, everything under STD should be called snake case rather than, say, camel case. Another well-known one is the core guidelines started by Bjarne himself. And this tries to deal with a lot of recommendation and guidelines. And this is a snapshot of the table of contents. And for each of those goes into depth with some rules. So it's just a random example. Another quite infamous one, some might say, is the Google C++ style guide, which kind of follows the same structure. You have a table of contents, they try to cover a lot of things, and then they go in depth with the rules. Interestingly enough here, as you will see later, the recommendation for 4 declarations are totally different than others. And because we are in game dev, a lot of people working in game dev use the 3D engine called AnnieL Engine 4 from Epic Games. And because it's written in C++, it comes with its own standard as well, coding standard. And here's a random examples of some of their naming conventions and guidelines and so on and so forth. Okay, so you kind of got a rough idea how standards work, or at least they're defined. How about actually adopting them and using them in practice? So first of all, they're generally laid out as documentation, either PDFs or wikis, internal wikis, so on and so forth. And the main idea is that people are supposed to read these standards, ingest them, and then use them in practice. And they're not usually machine readable, they're more for human consumption, like I said, with a couple of exceptions, one being the core guidelines themselves. They have like a Visual Studio kind of plugin that deals with static analysis and tries to compare the code against the guidelines and give you some ideas there. But as you go and use these, a couple of obstacles and pitfalls become apparent quite soon. Chiefly is that they grow big, the standard. They grow quite big and they become hard to navigate. A good example is the C++ core guidelines itself. It's quite large now. It's almost impossible to kind of read it, understand it in one sitting. And unless someone makes a dedicated effort to update them, they tend to grow out of date very quickly. Normally, like I said, they're in a separate location than the production code. You need to search and see where they are. And only the gods of programming for that particular project get to define and modify them. And who are we kidding, right? Nobody has time to read documentation. Everybody just wants to code. So with that in mind, you kind of maybe already see where I'm going with this. What's our new approach that we're kind of trying to hint here, that we pioneered in our company? So the big idea that the standards are actually source code files that participate in compilation. So I made here the joke that if you go and modify the standard, you add a new rule and you're not careful, you actually break the production build, right? Because it will compile as any other piece of code. also chiefly because the pieces of code, that means they are created and improved like any other code through to code reviews, which is quite powerful, as we will see. And they have a system for easy referencing and searching that I will show you very soon. So here's a snippet how they work in practice. So here's everybody's favorite IDE, Visual Studio, but this can be extended to any IDE. So see, without ever leaving the IDE, I just search for the coding standard and it immediately appears. So the time to documentation is minimal. I can just, you know, when I'm coding and I'm unsure about something, how did the standard approach this? I can just literally open it up in Visual Studio and look at it. So I think this is quite powerful. So going a bit more in detail, there are essentially two files. One H file, which deals with the more kind of architectural bits, and then a CPP file, which goes more in depth with like C++ rules and so on and so forth. And this is like an example of how they look in the source code, in the equivalent like source code location. And interestingly enough, we open source them. So you can go on GitHub and check for yourself our approach to these standards, fork them, use them for yourself, kind of try to find inspiration for your own maybe project. Here's a bird's eye view of the H file. Hopefully everybody can read it from there. If we go a bit in detail, we can see that largely is like comprised of either large commented areas that are supposed to talk about a particular technique, or actual C++ code that gives the intent, gives the example how you should use something. So here we encourage forward declarations quite a lot. Or they're a mix of either domain-specific things, like in this case, AnnieL Engine way of declaring classes, as an example how you should structure your code. If you wonder what the uppercase U class or generated body is, it's their proprietary reflection system. So either this domain-specific or just straight up C++ code that's supposed to prove a point. Here we're kind of hinting at the 350 rule with a nice link to CPP ref. And so on and so forth. Like for example, this is our idea how to structure virtual declarations. We kind of try to group them per purpose or like for the derived class that they you know, make sense. And interestingly enough, we actually recommend both virtual and override the keywords. We're also big on readability. We have a couple of things here, kind of disallowing multiple arguments of the same type, like functions with a lot of bools in a row, or encouraging strong enums for like better semantic readability. Game dev is really fond of singletons, so we try to make the point here that we shouldn't use them, and a couple of just paragraphs with ideas, alternative ideas. And so on and so forth. You get the idea how these are supposed to work. Now, if we take a step back and we kind of zoom out, right? You see that this is actually a full C++ class that can be instantiated and you know, participates in actual compilation. And interestingly enough, this was not intended at the time when we were devising this system, but because it can be instantiated, that means it can be part of the 3D world. So it turns out that you can actually create the standard actor example and give it a full 3D body and be in the world. Here, maybe he saw some bad code, that's why he's trying to fly away. Yeah, so going back to the standard itself, you might have already noticed these square tags things. These are inspired by the C++ ISO standard itself, and they're a way to easily reference things or sections in code reviews or handy searches, because you just remember this snippet, and then you search for it and find all files, and you find it easy. Where this works very well is code reviews. So for example, we use Perforce as source control, and this is a screenshot from a tool called Swarm, which does code reviews. And this is an actual screenshot when I say to somebody, it's better to use brackets class.member.def, which means that we encourage assignment at the point of declaration. And I think this is quite powerful because it kind of takes the pressure from being judgmental. That person is not supposed to do it just because I say so. It's because we all kind of respect the standard, and by referring to these snippets, it takes it, it makes it not personal. And there are a couple of additional benefits here. Like, for example, using it in this way, it's empowering for everybody. Like a junior could still hold accountable a senior to that third party, the standard, as well as learning by example. A lot of us prefer to learn by example. So having something already laid out there, you can kind of get inspiration, but you can maybe introduce something new first in the standard, see how it gets kind of traction, and then move it into production. Like, people will kind of copy it. So this is kind of the cycle. The standard itself was created through code reviews, and then you propose new changes. Like, normally when you code something, you send the code review to your coding buddy. With the coding standard, you send it to the full team. So if you get enough upvotes in a kind of democratic way, that's a new version of the standard, and that's how it grows organically, you would say. So let's take a bit of a deeper dive into the CPP file itself. Again, this is a bit more architectural than rather strict rule sets. It deals with our day-to-day work in AnnieL Engine 4 rather than be focused in the standard library. And remember, you want to kind of cater to all experience levels. You cannot be too expert-friendly. So sometimes you might want to spell out some things that are common knowledge. So we start with a bit of ground rules and layout. So we try to, even in this modern age of like super wide monitors, we try to encourage shorter column limits, even 80 or 100. Interestingly enough, Andre today in his keynote, he also recommended 80 characters. It's the one true way to code. Then moving on to more bike shedding, everyone's favorite braces. Because we follow the Epic game style, we do almond, and a couple of recommendations here. I should structure the code. We're big fans of early returns rather than deeply nesting stuff, and so on and so forth. Now, I know what you're thinking. Some of these things can be automated, and you're right. Like, some of these layout rules, instead of having it in the standard, you can also enforce them with linters or like things. And we do indeed offer a Clang format for people to kind of just run their code and make sure it follows the standard. But we don't necessarily enforce this. We try to be just as a teaching material rather than hard enforcing. Moving to some more bike shedding, everyone's favorite subject, auto, because especially in game dev, even after all these years, it's a hotly contested subject. So we start easy with a couple of generic deduction rules, then some gotchas, and because of these gotchas, we have the so-called golden rule that because CVness is not deduced, we try to be explicit. We encourage to put the qualifiers at all times. We're also big fans of the self-calling initialized lambda. Again, to this point that you should try to initialize at the point of declaration. And also this kind of saves you from like weird if statements or contorted ternary operator stuff. But because we have huge code bases and some of them they're quite legacy, we also have this like a disclaimer that sometimes maybe you shouldn't not go for auto and try to be consistent rather than create a mishmash and making it hard on readability. So we have the no auto style rule as well. We're big fans of lambdas. We have a couple of guidelines here, like use them unless they become so complex that you should extract them in functions. We are not big fans of wholesale captures like this. We try to encourage name captures. The same goes for capturing everything by reference, and so on and so forth. And again, we give a small kind of cheat sheet of the various deduction rules for like captures for 11 and 14. That's always handy to have. As well as memory. Memory plays a big part in game dev. Even either through throughput or speed. So we have a couple of recommendations here as well. But they're largely around AnnieL Engine, which comes with its own set of containers. And for example, here we encourage like the policy allocated technique at the API points, as well as a couple of like handy methods how to quickly empty a vector or stuff like that. Their equivalent of vector, which is called TRA, without losing too much speed. As well as a nice kind of small, I got it from Twitter and I put it in the standard, a nice kind of reminder of the access times from like the CPU register, which is the fastest, to L1, L2, and then main memory. And you can see it's quite a difference. So we have a couple of guidelines here, how you can improve your cache locality. Okay, so this is far and good, right? You have the standards, you define them, you work. How do you actually go about using them and adopting them in an organization? And splash damage is interesting because we have multiple projects going on at the same time. We have like, I don't know, 3-4 projects, and they can be in various stages. Some can be full-blown production projects, other can be more prototyping. This idea with the Standest was born in one project. It really took off, right? People really embraced it, the spirit of it. They grew it through reviews. So the key question is, how do you, distribute to the rest of a bigger company? When you try to do this, you will find a couple of obstacles. So projects, right? Projects can be different. Each project is unique in its challenges. There can be multiple differences across multiple points. This AnnieL Engine can be, it comes with various versions. You need to be careful what you put in the standard because it might not compile in another project. Different CI systems, servers, stuff like that. It's hard to kind of integrate some changes in a different project. And sometimes even contractual legal things that kind of, would make sharing harder. So interestingly enough, the solution that I already kind of hinted before was to go outside the organization and go to GitHub. That's why we open sourced the standard under a very permissive license. So you could integrate like you would integrate any third-party library. And we have a small team in charge of kind of overseeing this. And we call this team the core team. And it has a couple of, there's a select few people, and they have a couple of key responsibilities. They discuss the major changes that they want to do in the standard across the full company. They review and approve or create themselves pull requests in order to advance the standard. And once the standard has a new version, it's their responsibility to bring it back in their own project. But that's not enough, because this team is, like I showed, 6-7 people, and they're always busy. They're like in leadership. They don't have time. They lose connection with the ground troops, right? So more supporters needed. So we have the so-called ambassadors, which these are people in the projects that are interested in the standard, but maybe they don't care so much about the minute C++ points. So their job is to kind of spread awareness of the standard, or apply it throughout reviews, or like if they see someone coding and they're going too much against the standard, they're like, have you heard about the standard? Let's use it here. And also they meet with the core team once a month, and they discuss challenges. I try to integrate the standard in my team. Nobody wanted it. What can I do about it? Stuff like that, like create a healthy conversation. And of course, they can add the pull request after they worked with a particular thing in their code, and they think this should be used more throughout the company. So in conclusion, this kind of dynamic really worked for us when we have at the extremes the project themselves, and then the open GitHub, and then you have the core team and the ambassadors kind of liaising and making everything kind of work. This was quite beneficial, and it actually works. So what does the future look like? So there's always more avenues for teaching advocacy. If you yourself try to adopt standard in your organization, you'll see that there's always the need to teach and spread awareness. But I would say roughly half of the stuff in the standard can be machine enforced if necessary. Like I talked about client format and some other static analysis. There's always more tools work. It's harder with some of the other techniques, the more architectural techniques, but maybe some crazy idea like machine learning from a quite big history of commits. You can maybe extract some patterns and then you can say, oh, you're going against the standard. So things like that. That's some interesting ideas to explore in the future. And that's it. Thank you very much. I think we have some good time for some questions.
Hi, my name is Chris Hogendorn. My question is, what's the biggest advantage of having them compilable instead of like checking it in as a markdown file where you can also do pull
Good
requests?
question. So what's the biggest advantage? I think the biggest advantage comes to the code review, right? An ability for people to learn, like what's the benefit of code reviews? You get a chance to fix stuff, but also you get a chance to learn, right? Like someone can shadow someone and through the code review learn. So I guess they really come into play in code reviews because you can both reference them in your code, or they're more easily expandable themselves, right? You can push a code review immediately with the standard rather than going someone writing in a corner, whatever, the standard, and then trying to put it back in production.
Yeah, but I'm saying, like, what if you write it down in a markdown file and put it also in your archive? Then it's not compilable, but it's still, you have all the benefits of having it in a code review and stuff like that.
Learning by example, like sometimes you just want to learn how a particular character class. It becomes very domain specific. Like when you declare stuff in game dev, you need to partition some things like this or like put some things like that, right? So it's a nice template to have. Like I didn't show there, but there's actually a character class with it's all this like gameplay abilities and stuff, and you can use that as a teaching mechanism or as a template, and it's actual code right there.
Okay.
So even you can go maybe copy pasting, right? You copy paste that portion and then you extend it, and you have good confidence that it came from a good place. It was actually from the coding standard. It was compilable. It's first citizen.
Okay, thank you.
The microphone takes.
Okay. So I have a question about the client format, because I know you mentioned that you have it as an option, but you don't enforce people to run that. I was just curious, why not? And also, why not just add it as a checker on commits? So every time someone commits, it just automatically runs that.
I think we should do that. Even in the company, someone already kind of channeled your ideas. I think that should be a good idea for the future. When we started it, it kind of grew, like I said, organically. We kind of just pieced it together. Mm-hmm. But now it's in a good shape that, it can be better tool enforced, I would say.
Yeah, thank you.
Hi, I just wanted to ask, how do you handle large standard updates that you cannot automate? Do you have to make scope for those changes to do them manually?
Large standard, in what sense?
Like, let's say you all vote together and you decide we're going to change some style thing. Clang format, Clang tidy, it cannot handle that. You have to make scope to do the work manually. Is that something that would dictate which styles and which standards you can apply?
I guess that's where that core team comes into play. You discuss, right, because you have a representative for hopefully every project, so you don't create too much tension. And then they discuss, okay, it's time to completely refactor some things. So you push the new version, and that's kind of gospel now.
Okay, thank you.
Hi, Dave Fleming. Do you have any recommendations on how to deal with legacy code that has various different kinds of coding standards and different styles? Would that be something?
Having this standard is the first step. Like for example, we have a project where we don't have that. It's legacy, quite a lot of it, and we don't have so much control. It will be impossible now to go back, right, to retroactively change. But we still put the standard there as an intent. So now every new piece of code kind of carries the standard. So at least going forward, you have a chance to fix the mistake.
So you don't recommend going back and trying to fix all the old code?
If you have time, like if you can convince production, sure. But if nothing else, we still introduce a standard as like a flag saying,
Yep.
you should do it like that, even if 90% of the thing doesn't follow it.
All right, good. Thank you.
Hi, you mentioned that if you change the standard file, the whole build will break. How does that happen? The compiler will still be happy. Is that some kind of proprietary system that you have?
Well, we do have pre-commit checks and stuff like that, but I was kind of making the point that this is actual source code. So yeah, who knows? Maybe if you're not careful, you do introduce a mistake. But it is true that we have a couple of gates like code review, then pre-commit check. So in reality, it's quite hard to break the actual production code with changes to the standard. I was kind of emphasizing the point that it's actual livable source code.
Thank you.
Okay, I think it's. Thank you very much.